So, let's kick things off diving into the design of a URL shortening service, almost like how TinyURL works. It's all about turning a long URL into a compact, shareable link and then redirecting users back to the original URL.
Right? It's one of those classic system design challenges. And the first thing you consider is what the core functionalities are, isn't it?
Exactly, it's like thinking about two different flows. First, you have the URL shortening function, taking a long and unwieldy URL and generating a simplified link.
Yeah.
And then secondly, the redirecting process, where the system retrieves the original URL when someone clicks the short link.
And when you think about the scale, we're talking about potentially 100 million URLs being generated per day, right?
Right on. At that scale, you have to ensure high availability and rapid processing for both read and write operations. It's a balancing act between performance and reliability.
And then there's the data storage requirement. We're looking at potentially hundreds of terabytes over a decade if you factor in billions of mappings.
Absolutely, and that leads us to the high level design. Imagine sketching out the system. First, you propose your API endpoints. One endpoint, a post like its API v1 data shorten, takes in a JSON object with a long URL and spits out the short URL. And then there's a get endpoint,
Yeah,
something
I
like
get that.
API v1 short URL, which handles the redirection to the original URL.
So essentially, the API design lays the foundation for how clients interact with the service. But wouldn't you say that the type of redirect, 301 or 302, can really influence some design decisions?
Yeah, that's a good point. A 301 redirect caches in the browser and can help reduce load on the servers, whereas a 302 might be more useful if you want to capture certain analytics like click counts in real time. It's these details that show you're thinking through the performance impacts.
And speaking of details, let's talk about the data model. Initially, you might start with a simple hash table mapping short URLs to long URLs. But over time, this needs to evolve, right?
Yes, definitely. In fact, starting with a simple hash table is like the starter blueprint, but then you need persistence. Using a relational database, maybe with a table that features columns like ID, short URL, and long URL, ensures that your mappings are
Right.
durable.
I've been wondering though, don't you think a relational database might have limitations when we consider such astronomical scales?
That's actually a fair critique. Upfront, a relational database might work well, but at scale, you'll have to look at techniques like sharding, replication, and caching. It's all about partitioning the workload so that the database doesn't become a bottleneck.
So you're saying that while this simple model is fine for initial designs, the long term plan needs a more distributed approach.
Exactly. Now, onto one of the coolest parts, generating the short URL itself. There are two popular approaches. One uses a hash function with collision resolution, perhaps MD5 or SHA1, taking the first, say, 7 characters of the hash, but
hmm
you need a mechanism to handle collisions when two long URLs produce the same truncated result.
And the alternative is the base 62 conversion, right? That's pretty elegant.
Yes, exactly. You take a unique numeric ID, ideally from a distributed unique ID generator, and convert it to a base 62 encoded string. Think about it. Base 62 uses digits 0 to 9, lowercase letters, and uppercase letters, which makes the resulting URL both compact and, well, unique. It's like turning a number into a string that looks casual but is like intricately calculated under the hood.
That's nifty. The base 62 method is straightforward and avoids many collision issues. But what about the hash method's collision resolution? That must add complexity, right?
Right? And that's where its downsides come in. You need extra logic, maybe appending more characters if there is a collision, or using something like a Bloom filter to check for uniqueness quickly. It's like, well, the complexity versus the simplicity of base 62, which usually wins for URL shorteners used in high throughput scenarios.
That makes sense. And then, when it comes to the system flow, think about the client sending a long URL, the system checking if it's already been shortened, and if not, generating a new mapping. Eventually, when a user clicks that link, the request passes through a load balancer to the appropriate web server, and you either hit a cache or go to the database to retrieve the original URL.
Exactly. This system flow is critical. because you gotta design for both speed and reliability. The caching layer is vital here, as it minimizes direct database hits for frequent requests, keeping the response time
Yep,
super
that's
low.
key.
It's like making sure that your favorite pizza place has enough delivery people to handle rush hour orders.
Haha, that's a good analogy. But let me ask you, how do you balance the frequency of writes versus reads? Especially when, say, 100 million URL generations and a significantly higher volume of redirections are in play.
Excellent question. The dry read and write operation ratios here are like a huge factor in the design. The system might actually face a much higher load on reads than writes. So you optimize for fast read operations by using load balancers and caching strategies, maybe even employing content delivery networks, CDNs, to speed up redirection for users far away from the source server.
So the overall approach is to layer the system, a robust API on top, a smart data storage strategy in the middle, and a caching system sitting front end to handle all those incoming requests.
Exactly. And don't forget about the security and abuse aspects, implementing rate limiting to safeguard against malicious usage. You don't want just anybody spamming your system with short URL requests, right?
Uh-huh. That's a very crucial point. Also, monitoring and analytics can help you see which links are really popular or perhaps detect any suspicious activities early enough.
Yes, analytics round it all out. In a system design interview, showing that you have thought through performance, scalability, and security shows a deep, holistic understanding of the problem space. You might talk about integrating monitoring tools for click through rates and traffic patterns.
I've always felt that such details make your explanation really robust. But sometimes I wonder if interviewers go too deep into these details. Don't you think it can be overwhelming if you dive into, say, complex sharding techniques without enough time?
That's a fair critique. It's all about reading the room, or in this case, the interviewer. You need to balance depth with clarity, making sure you cover the essentials without dragging on. If the conversation starts to go too deep into one area, you can always ask if they'd like more details.
Mm-hmm. So the key takeaway really is clarity and balance in your design explanation, correct?
Exactly. You want to communicate that you've thought through the problem systematically. Start by clarifying the problem, draw out the high level system blueprint, discuss the API design, and then dive into specifics like the data model and hash function design. It's, well, a structured approach that covers all bases.
And let's not forget scalability. How do you envision scaling such a system when it comes to handling billions of URL mappings over a decade?
That's where load balancers, stateless web servers, and advanced database optimizations come in. You might incorporate sharding to distribute data and replication to ensure high availability. Caching is like the secret sauce, ensuring that frequent lookups are handled swiftly.
Right. These strategies ensure that even under heavy load, the system remains responsive. It's almost like preparing a stadium for a big concert. You need the infrastructure to handle the massive crowd.
Exactly that. And if you add analytics monitoring and perhaps even a rate limiter, you can proactively manage both performance and security.
It sounds like, fundamentally, the design is as much about building a reliable service as it is about scaling to meet the demand and anticipating potential abuse.
Absolutely. And remember, when you're in an interview setting, articulating these reasoning steps clearly, starting with clarification of the requirements, then describing your high level blueprint, followed by deep dives into specifics, really shows that you're methodical and can think on
Yeah,
your feet. You're
I like that. But, don't you think sometimes candidates might over-engineer? I mean, is there ever a risk that by focusing too much on every single detail, you might lose the bigger picture?
That's a valid challenge. It's definitely about balance. While you need to demonstrate depth, you also need to step back and articulate the overall flow. Sometimes focusing too much on minute details can um, muddle the clarity of your overall design. It's like you want to be seen as both a big picture thinker and someone who can handle the nitty gritty when needed.
Mm-hmm. And that balancing act is what truly sets apart a great system designer in an interview.
Absolutely. In summary, designing a URL shortening service is a classical exercise that encapsulates many fundamental aspects of scalable system design. From understanding core functionalities, building out efficient APIs, designing a robust data model, and managing scalable infrastructure, every piece matters.
Definitely. And I think this design also serves as an excellent example of how to tackle real world problems methodically while keeping the conversation with your interviewer both detailed and digestible.
Yep, exactly. With this kind of approach, you're not just solving a problem, you're demonstrating a holistic method to handle system challenges. And that's like a priceless skill in tech interviews and beyond.
It's been a super engaging discussion. Any last key takeaways you'd want to emphasize?
Just to reiterate the importance of asking clarifying questions, laying out your assumptions clearly from the start, and then building a structured design that factors in scalability, performance, and security. Stay curious, think big, and always be prepared to pivot if new requirements come up during discussion.
That's solid advice. Designing systems is as much about the journey of exploration as it is about the end product.
Totally. And if you can articulate your reasoning as you go, you'll not only ace the interview but also be better equipped at solving complex, real world problems.
Well said. It's been great breaking down the art of data modeling, API design, and scalable infrastructure with you today.
Yep, thanks for chiming in. I hope our chat today gives listeners a concrete framework to approach systems design challenges one step at a time.
For sure. And thanks everyone for tuning in. Stay curious, keep designing, and see you next time.